Ladies and gentlemen, please take your seats. Today, many of us have got up 4 o'clock in the morning, so time we have now for some of us means that we are very tired. At least I am very tired, but I hope that everyone is here, that you have eaten. Okay, so there will be latecomers coming into this room. I have decided to stay right on time. It's 3 o'clock. So make yourself comfortable. Okay, so in such case, let's have a brief introduction into the upcoming session. I'm going to ask you a handful of questions. I'm sure people will be coming in, and I would like to ask the first question: who went for the morning walk to Białowieża forest? Małgorzata, okay. Okay, so who went to the forest but was not supposed to go? Well, who didn't go but wanted to? And who did not go because they couldn't? Okay. Okay, so who's got Pete behind their nails? Who had Pete behind their nails? Okay. Who has clocked in the biggest number of steps? Okay, check it out. Check it out, and you know, whoever has the biggest number of steps. Okay, so who's breaking today's record? 28,392. Anyone got more? I wasn't supposed to win. Okay, so who had a bit less? A tad bit less. Okay, so you get the award. Madam Director has giveaways for you. Okay, who got lost in the forest? Okay, well. Okay, the smart lot. Who had to work? Okay, Ella had to, but she did it with joy. Who didn't like it out in the forest? Okay, Madam Director did not like it. It's a pity. We are very sad. It makes us very sad. Who liked it then? Okay, we have votes which are withheld. I'm not looking at you. I'm holding the mic so I can do more than you can. Okay, so on this note, after lunch, I hope that we are more active intellectually. So coming up next are 2 sessions, and hopefully everything we did in the field. And we are going to have more time in the evening to have a Hyde Park discussion. So all your insights and emotions, let them stay with you. And right now, let's start with session 8, which suddenly became session 7. And Tomasz Krepski, the floor is yours. Okay, so can I have Tomasz Krepski slide the response of bentos invertebrates to restoring activities. Hello, I'm Tomasz Krepski of the Institute of Biology of Szczecin University. I would like to thank organizers who gave me this opportunity to share my insights. I've been conducting studies into invertebrates of Drava River for many years. And first, I would like to say, because we have two difficult words, benthos invertebrates, what does it mean? If there is one person in this room who thinks invertebrates are slimy, So these are living organisms living in the bed floor, and it's a very diverse group. They can live in sand, in gravel, or in aquatic vegetation. Okay, so this is how they look like. These may be water snails, leeches, crustaceans, and this group also includes insects, larvae, and imago insects. So the largest group is made up by stoneflies, caddisflies, and mayflies, and this is the index used to evaluate the status of water in many countries. It's one of the bioindicators of water in rivers. Of course, you can have dragonflies and different water beetles, but they are rather popular on peatlands, not in river. Okay, so let me discuss my research. Recently, I've been to a study visit in Austria, and I was surprised because they did not believe me when I said that I was taking samples along the river Drava. Of course, I meant Drava in northwestern Poland, that's tributary of Noteć. The length of the river is approximately 186 kilometers. It's flowing from the north to the south across the river Oder and Warta. When I was writing my doctoral study, I went out in the field and I didn't know where the river is running, so I got lost several times. So the mouth is close to this town of Krzyż Wielkopolskie, and the river Drava is not only the subject of our research. This is where we stand as the faculty a lot of time. We conduct research non-stop ever since 2007. We were exchanging insights, philosophical and academic, on the banks of this river. So this river has become very dear to me. And quite recently, a live Drava.pl program has been completed. Right now it's followed up as Drava Bees program, and the program included a number of restoration activities. For example, we have built riffles, fish passes, and we have reintroduced and improve the habitat for ranunculus. I wanted to discuss 3 mini projects we have implemented as part of restoration activities. The first one, we were evaluating fish passes as a potential habitat for benthos invertebrates. Secondly, we investigated the impact of changes in the substrate on groups of benthos invertebrates. And the third project, which continues until today, is ranunculus as a potential habitat for invertebrates. I'm going to discuss initial results today. Hopefully you'll find them exciting. So let's start with fish passes. On the photograph, you can see the most spectacular result, the fish pass, which has been built next to Kamienna water power plant, the oldest worldwide, built 5 years after a similar facility was built in the US. And because of the size of the fish pass, we've decided not to assess it as a habitat. So we focused on the 3 passes. One is located close to Głęboczek, the other one close to Słupice, and the third one on Korytnica River. On the photograph you can see the first fish pass in the town of Przetłoczek. The second one on Słupice River is a circular channel with passes with stagnant water. This is an area for fish who are swimming up the river, and this is a place where they can rest. So places where water is stagnating are home to very distinctive habitats for stagnant waters. We have very typical vegetation for such waters. And the third type of bypass, featuring stones. What do? They slow down the current. There is no place where the water would stagnate. The water were turbulent before, so one could think that this pass would be least likely to create a good habitat for benthos invertebrates, but we proved otherwise. We checked which invertebrates live above, inside, in the tree, in the fish pass, and below it. And we have calculated a number of variables, and I'm not going to bore you with them, but I'm going to select the most exciting ones. The number of taxons, how many invertebrate groups we found in different habitats, the count of invertebrates, which will tell us about the food supply in the river, and the 3 previously mentioned orders of insects, mayflies, caddisflies, and stoneflies, which are living in the river habitat. On Drava River, where we had rapid fish pass, we had a relatively low count of invertebrates compared to a section upstream in front of the dam. And also the count of invertebrates in the pass was very low. We have found stoneflies and lots of mayflies, what may prove that the current is the perfect habitat for them, but because of the strong current and homogenic bottom, other invertebrates do not find it a good place to live. Słupice, where we have chamber passes. We were struggling with sampling above the dam because it's very long. The runoff is very powerful, so we were sampling in the dam reservoir, and because it's a chamber-shaped pass, in the past, we have found a relatively low count of invertebrates and taxons, but it was a mosaic of stagnating and rheophilic species. And the pass on Korytnica River, which may seem to be the least appropriate habitats for invertebrates, lots of concrete and stones, and we were taken aback by what we found inside because the number of taxons was very high. And I would like to draw your attention to the count of invertebrates in the pass and the count of mayflies, caddisflies, and stoneflies, much higher in the pass than in the river upstream and downstream the dam. So this proves how wrong we were initially, because this semi-chamber pass, which is not creating small pools of stagnant water, but has regular flow, provides the perfect refuge for rheophilic species. And I should also mention that amongst stonefly found in the pass, we found species never ever seen before in Korytnica River, which is why I have 4 conclusions. Passes create unique habitats with specific composition of invertebrates. Chamber and semi-chamber passes are characterized by higher diversity of invertebrates, and semi-chamber paths are a safe refuge for current-loving species. And the 4th conclusion, we know that passes are mainly built for fish, but if we select the right pass, it may become a refuge for biodiversity of rheophilic invertebrates. And another mini project, we are studying gravels. You can find such sites all over the catchment areas. The river Drava flowing across Prosinko. You can't see it on the photograph because hydrotechnical work has been conducted downstream, but we had 4.5 meters width of the channel and depth of just 0.16 meters, and current speed was slow, 0.2 meters per second. We had stony bed with lots of silt and vegetation below 10%, and the riffle was created last year. Another site located in Kuźnica Drawska, the width 2.67 meters. The river was relatively shallow and current speed stood at 0.225 meters per second. We had stones and sand on the bottom. We had heterogeneous bottom. You can see vegetation, and the riffle was created in 2019. Another site in Rzepowo, the river has grown larger. Its width exceeds 5 meters, depth accounts for almost half a meter, the speed stands at 0.3 meters per second, and in 2019 the riffle was created. And the final site in Drawska Pomorskie, where the width exceeded 12 meters, the depth was almost half a meter, and current speed was less than half a meter per second. Sandy and silt bottom with very little vegetation and not very diversified bottom. When we arrived to take samples in 2019, we are calling our friend and asking, where is the gravel? Because we are walking around the river and we don't see it, and the gravel was laying on the bank. Which is why tests were conducted a bit later, and these are results. This vertical line, this is the time when gravel was added to the riverbed, and samples were taken up stream where gravel was added and downstream. So we have a control sample and the impact sample. And you can see that in all rivers, which were a bit smaller, a bit narrower, when gravel was added, the number of invertebrate taxons went down by double in Prosik and Kuźnica. And it should be stressed that the number of taxons was not only diminished in the impact sample, but also in the control sample. Why? The answer to this question is ready to be presented, but I will present it in a minute. Control sites are upstream of the site where gravel was added. And in Rzepowo and in Drawsko, where the channel is a bit wider. In Rzepowo, you can't see major changes. To be frank, recent tests indicate that Rzepowo was restored to its original state, where sand and gravel was deposited on the floor of the river, on the bed of the river. In Drawsko, we've got a bit more gravel, but no major changes observed in Rzepowo. In Drawsko, So tests were conducted in autumn 2019 before gravel was added. And after 2019, we can see that the expected number of taxons went up, in fact. And the same goes for the count of bentos invertebrates in Prosinek. The count of invertebrates drastically went down in Rzepowo. Crustaceans got more living space, and the count of one group went up dramatically. In Rzepowo, the count was diminished, but the population is on the rebound. And in Drawsko, when the gravel was added, in the control sample, the count was greatly reduced, but today it went back and is higher than before gravel was added. We were wondering why this happened, why gravel had an impact on invertebrates upstream of the impact site, and why everything worked well in Drawsko. To answer the first question, I was trying to answer this question. I was passing past Robert Czerniawski's room, and he was getting ready for his classes with students, and that's the slide he was looking at in his computer. Lots of insects during the mating season, and when they are getting ready to lay eggs, they are taking compensation flights upstream to prevent shifting population by drifting. So when gravel was added to the river and the number of taxons and the countdown of creatures went down, many taxons went upstream to lay eggs there. And that's probably the reason why the impact of gravel was so great on invertebrates at the site where gravel was added and upstream of this site. Why did everything work well in Drawsko? Because we had a homogenic bed, and the section was located in the middle of a small town, a town which is very urbanized, where the riverbed is built over and regulated. When the bed became more diverse, we had pools, pockets of stagnant waters, and as a result of major biodiversity, we had the arrival of new invertebrates never seen before at this site. Probably the river is purifying itself in this section. So what may happen later? We conducted our tests over a period of 4 years. So this is a new paper from 2026, which analyzes 10-year period after adding gravel to the river. And they conclude that there is high biodiversity, and this biodiversity increased when gravel was added. But taxons and invertebrates, which were not expected in this river, arrived to the restored section, and there are certain claims which suggest why it is so. Why not the expected taxons, but different ones are now living in the river? One theory claims that we have no idea what the river will do, that rivers are unpredictable. Scientists assume that certain habitats would be formed, but the river created very different ones for different invertebrates. Biodiversity was on the rise. Should we be happy? Yes, we should, because every restoration of human errors is a success, but scientists stress that restoration requires monitoring and it should go hand in hand. And I have three conclusions. Change in substrate has an impact on biodiversity of benthos in streams and upstreams of rivers. Creating sequences of riffles is most beneficial for the fauna. And very briefly, our initial results from tests on fauna living in ranunculus vegetation. And we've decided to take a closer look. What is living on ranunculus vegetation? I'm presenting results from autumn this year. Today over breakfast, my colleagues from Warsaw said that biologists always create tables, not graphs, after tests. And let me discuss and explain what this table shows. We have collected 30 layers of ranunculus in winter, in January, and it should be stressed that ranunculus is an all-green plant which is also found in rivers in winter. And on the layers we found a Diptera from Simonida order, which sticks to the ground to filtrate water. We found them on 23 out of 30 layers, a huge count. And what does it mean? It means that by protecting the ranunculus or creating a good habitat for ranunculus, we are helping the river to clean itself, because we are creating a habitat for filtering organisms that can last all year long, not only in summertime. And last but not least, three summaries, three conclusions, but perhaps I'll say something from myself. I would like to draw your attention to the fact that restoration is very often not monitored. And sometimes monitoring is launched after restoration has been completed. We have Maciek Chomiczewski in this room. We have Artur Furdyna. I used to run away from him because every time I wanted to engage in a restoration project, he would say, I'm coming to monitor whatever you're doing. So next time you'll try to obtain money for restoration, please remember about earmarking funding for monitoring, because we need to know more about what happens when restoration comes to an end. Thank you very much. Magda is saying that we are not finished with restoration as the process is complete. We need to see how it works, what's the efficiency of the process. So I think you meant when the project is completed, that's what you meant. Okay, thank you very much. So this is the session about the efficiency of restoration projects. Tomasz Krepski has to leave and go to Drava River. He knows how to navigate his trip and his route. So that's the only time to ask questions to Tomasz and Ewelina.
I can't wait to ask the question. I agree and I congratulate you on the final conclusion. But it seems to me that there is one element that appears yet another time in my head today. If we are doing monitoring, if we are measuring in order to assess something, we need to use the correct measures. More doesn't mean better. We have the biggest number of trout in the ponds, which doesn't mean that more taxons or more biodiversity in the right section is the adequate result. As we've seen, those fish passes not necessarily are adequate for this type of drava, especially the concrete fish passes. So we are creating something like a Disneyland. And it's easier for us if we're working with fish or habitats because it's easier to create the reference system because we don't have so many taxons and so many animals. But I would recommend very strongly that if we are carrying out this type of research, this type of studies, we should first create the measurement to which we will compare the success, because the conclusion that there is more doesn't necessarily mean that it's good. I agree completely, and notice I never use the word biodiversity, and I didn't say that it's crazy biodiversity. Yeah, it's not something tangible. And I agree, we need a reference point to benchmark the effect. This is very right. Unfortunately, fish passes, as a rule, are anthropogenic. This is not natural. So we don't have this reference measurement. So I've treated it as a place for the species that are already in the Drava River. But because we changed those species, their space change, but in the fish pass, they can survive more difficult periods, for example, of low waters. But I do agree, yes, more doesn't mean always better. My question is, maybe not a question, but a comment about the riffles, because they have been created in order to create spawning grounds for the fish, right? For the improvement of their existence. No, I don't think so. Improvement of the conditions for traveling fish, so for the spawning grounds, it was in another section of Drava. Maciek, hydrotechnician, said it more professionally, but this is the improvement of water relations, yes, or something like that. Well, since we are talking about invertebrates, the conditions have to be quite special, and I suspect that there were no more taxons from EPT group. So I think that this is because of the relationship between depth and speed and the bed substrate. So I'm wondering what was the reason that given taxons increased or didn't increase their occurrence. Yes, I didn't say that creating the gravel bed is, or the coarse substrate is the reason. It's not the reason for the benthos to disappear. But there was a small place where we were doing it. We have hypotheses that we will test, and something was wrong with the proposal of organic matter. We have a few ideas, and I'm sorry, but people are not speaking to the microphone. We don't know what they're saying. In many places, this is not a direct reason, or it might be an indirect reason. We're still looking for direct reasons. We have hypotheses. We have started to write projects with some people to get more answers. As I've mentioned, restoration itself or its effect is not so easy to forecast insofar as what will be happening with the ecosystem. Professor Wagner. Excellent project. I'm very happy because this is a topic close to my heart. The question, why didn't fish appear? It didn't appear because you didn't do it, or you didn't evaluate the results? Because I'm curious. You didn't study fish? We did. So what did it look like? Isn't there a greater transfer up the pyramid? I would like to ask an ichthyologist from our chapter. Yes, we've done those studies, and you were able to actually see it with your own eyes. Insofar as
Tak, no to ona decyduje o wszystkim. Fizyka najpierw, później.
so physics, chemistry, biology, this is how it's happening.
Ten prąd w prosinie był mały, no tam właściwie jeśli chodzi o
So when the current is not strong, nothing changed, the same species remained. Well, fish is more mobile compared to invertebrates, so they can change positions, they can move, they can travel. So even gravel audition in draft square, everything was perfect, where it all really improved, might resulted that the fish from that riffle moved 100 meters below to the place of this gravel bed, but that doesn't mean that the fish wasn't there on this section. So yes, if I were to be honest, I believe that fish is not a good indicator. They are not a good indicator at all, as I believe. Piotr, I'm careful with what I'm saying, but they are not a good indicator for such small changes, small facilities like riffles, because fish move simply. And like the Institute of Inland Fisheries is doing for Gyosh, well, this is the right method, whatever they use. But I believe that this is not right. I know, Piotr, that you agree with me. I'm just going to say that the greatest success insofar as fish were the activities in the downstream of the Drava and the fish pass in Korytnica. This was the greatest success. Fish started to be more numerous. If we are doing gravel riffles, we know what species we might expect, but when? Only for the time of spawning and development, and afterwards this fish disappears. They only use it for their as their bed to do we know very well what, and that's it. This is off mic, so we can't hear the speaker. Transportation of the matter up the network. This is an element that could impact the number of fish. Well, they could find some bentos invertebrates to feed on, but they didn't because it wasn't there. It's typical for roaches, for instance. The trout was there only for a moment because it's spawning there and afterwards it disappears. Restoration is supposed to bring the first effect because we talk about biodiversity as the final effect. Yeah, increasing biodiversity. This is a slogan which is supposed to ensure the funds. It needs to appear when they check it in some institution and the administration that if this word doesn't exist, they say added there because you didn't say that it's about biodiversity. So we write it. And we write also about sustainable development, and then we have 50% points more. But this is not the lady sitting next to me. No, absolutely not the one. And we have 3 basic goals in the end, starting from the top, from the final thing that we have to have for the funds, which is biodiversity, the least important in my opinion. This is my private opinion. Then the number of species and how numerous they are, and at the end chemical changes resulting from enzymes excreted by algae that are growing there. So this is the first indicator, and afterwards the improvement of hydrological conditions like the current and stabilization, as Maciek says, stabilization of hydrological conditions. So if we don't fulfill all these conditions one after another, we will not achieve the final effect. And to be honest, every single one of these stages requires monitoring. Yesterday, Professor Zalewski was talking about the atoms and red algae, and this was very important. We cannot forget about it. If we overlook it in monitoring, then again, what we'll say, well, restoration didn't work out. Somebody will come who will only add gravel there, and they'll say, okay, we need to add something, or we need to take something out, and the effect will be somewhere else. I'm just gonna add to what Professor said. He's absolutely right. To all the people who are writing these applications, and for the people who are assessing these applications from the administrative perspective, and they don't know much about it. Biodiversity is not the number of species. There are indicators of biodiversity. There's Margalef indicator, which takes into account how many there are in the species, and it's compared. So that there might be 15 or 20 that will appear, and we are happy that more species appeared, but it's not biodiversity because other species disappeared. Biodiversity in this way, well, we can destroy the river or that section. We need to pay attention to that very much. Tomek, we have to go now.
A ja chciałem jeszcze tylko jeden temat do Hyde Parku, bo tutaj...
I wanted to add one topic to Hyde Park because I don't agree with two things. First of all, what's lacking? The best assessment we had with the habitats is the structure of the team, and we have proof for the fact that there is a clear answer of fish, but also other water organisms to the habitat on the right scale. But sometimes we are measuring in the wrong scale, but we all know that in the riffle there will be a different composition in riffle compared to pools, etc. So this is how we differentiate it. So I don't believe that measuring long sections answers the questions. This is a wrong answer to restoration, because if we have 10 pools, for example, we need to have the right species composition that would answer to that. Yeah, I do agree with what you said. I was just correcting my colleague. Okay, so I'm gonna join in and we will continue. Tom, the problem is that you have to go. We'll talk about you and you won't be here, so I don't know if this is a good idea, because you have encouraged us to have a great discussion unless you stay. So please stay.
Ja myślę, że to był bardzo fajny wykład do dalszej dyskusji.
I think that it was a great lecture, and I think that the discussion will be in the next panel. And now I'm gonna introduce a few more presentations by the representatives of IMGW. This is an introduction to your presentations. This is from the Center of Hydrological Protection of the country. We talked about meandering, restoration, etc., etc. Everybody is right. We know everything. Everything is great, but not necessarily everything works afterwards. I think that we have to remember that we don't know everything, and it's worth stressing. Restoration measures are engineering works, and engineering knowledge, project knowledge, design knowledge is important. So we limit the process of randomly choosing whatever will come out in the end process. Someone said here that we cannot foresee what will happen. It's true, but we can limit the effects. Water will not excuse any mistakes, and the more impact we foresee ahead of time, the more we'll be able to limit negative effects. And my experience tells me with all activities with water, we need to diminish negative impact and afterwards look for positive ones, because otherwise we can spoil a lot of things. So this project approach in restoration processes is very important. Defining goals, good planning of our activities is of key essence. To plan the right activities or measures, we need to have basic knowledge so we know what we need to count based on what, analyze what effect to expect. So the knowledge within monitoring that we talked about, the zero state that we compare ourselves to and from which we want to go up to some better effect. And the second database is the database of hydrological data, spatial data, and we will try to talk about this data because they are this element that allows us to draw conclusions and to control whatever we will do. Because the monitoring, the post-monitoring, and the results are very interesting, and they give us a lot of conclusions. And I'm talking about those results that Tomasz Krebski just has shown, but this is 1 year or 2 years afterwards. And as Professor said, Professor Grigoruk said that what's lacking very often are the means, the funds for such research, such studies. So let's hope that there will be funds for such studies in the long term, because I believe this is very much needed. And the conclusions from post-assessment are also very important, so we can correct the measures, the activities that we are doing on everyday basis in the project, because no matter what we see in the numbers afterwards, the final effect you can see in the field. And those conclusions post-project conclusions are the best for us. And the second one is the hydrological database and the database of tools or instruments, modeling tools, designing tools, and our super experts will talk about that.
Dzień dobry Państwu. Bardzo dziękuję Maćku za wprowadzenie. Poproszę tylko...
Thank you very much for the introduction.
Rano byliśmy w terenie, byliśmy hydrologami mokrymi.
In the morning we were in the field, we were called hydrologists, and now become dry hydrologists. In the meantime there was lunch. I hope that we won't be falling asleep. I hope to keep your attention in as long as possible. My name is Paweł Przygrodzki, and I have the pleasure to manage the Center of Hydrological Protection of the country in the Institute of Meteorology and Water Management in the State Research Institute. Just one introduction, one word of introduction. What is the Institute doing within the hydrological protection of the country? Hydrological protection of the country is one of the tasks of our service. This is according to the water law. Within this process there are four main sub-processes that are being implemented: monitoring, modeling, forecasting, and warning. And the products from these four basic sub-processes are of course warnings that you receive, forecasts, and also other products, bulletins, messages, reports of various types, and expertise. And who receives this information? Of course, the society, the services, institutions, and other entities related to water management, water economy. So one of the main tasks of our service is to informing and forecasting about the current hydrological situation and warning against extreme events related with excess or insufficiency of water. But these four processes or sub-processes that I have listed can be also used as support for analysis for restoration activities within the context of increasing the hydrological safety. I'm calling it like that on purpose because we sometimes also deal with excess and insufficiency of water. Again, so this support can be about four basic aspects: the data and hydrological products, spatial analysis, information obtained from IMGW service. And these elements will be discussed by my colleagues, experts Joanna Depta and Małgorzata Gori. Both of them came from quite far away. They represent the Institute and the Krakow region. And I'm going to talk about a different topic, the application of hydrological modeling and hydraulic modeling for the analysis and the assessment of effectiveness of restoration activity.
Dzień dobry Państwu. Małgorzata Gori. Pani organizator mnie poprosiła.
Hello, ladies and gentlemen. The organizer asked me to say something interesting at the beginning, and I had a difficulty. I realized I have no interesting things to say, so I can't say anything. But the guide in the forest helped me with that, because I told him that I came from Babia Góra park. This is where I was born. In the buffer zone of this park, and he told me, oh, this is interesting, this is quite interesting, so I have something interesting to say. And ladies and gentlemen, my topic is the use of data, of hydrological data from the IMGW PIB in river restoration. I just need to learn how to switch slides, or am I doing it too fast, maybe? Don't be scared of these slides. I'll try to... I hope that I'm going to explain everything in a simple manner. Ladies and gentlemen, I'll start with the introduction. Restoring the natural characteristics of rivers that have been lost as a result of human intervention. This requires to identify effective measures that will take into consideration local conditions and the goals, natural goals, environmental goals, social goals, etc. So adequate planning, designing of the restoration process. I could even say that a picture of this hydrological burden in a simpler decision taking by designers. But after the implementation of the restoration measures, in order to assess the effectiveness of these measures, we should start the monitoring process to check if we have implemented correctly the process, so the so-called systematic collecting, analyzing and interpreting data on the condition of the river. And this should bring us closer to a correct planning, or checking if we've taken those decisions in a correct manner. And hydrological data should help us with that as an element in searching for good solutions. I'll start with hydrological information and what does it mean, and what I'll tell you about in this presentation. What are the types of hydrological information, how we can process it, how we can obtain it. We can obtain this measurement data, but we can also obtain the results of hydrological modeling. Dr. Przygrodzki will talk about that in his presentation. and what is the temporal resolution of the data, what is the area coverage of this data, how available they are, how accessible. And I'm going to tell you also what are the limitations in the end, and how cautiously we need to approach this data. I told you about the types of hydrological information, and we can divide it into data. So basic characteristics of hydrological characteristics, different types of phenomena or events, precipitation, etc. And products are the data which is the result of data processing, and we can use it for a specific purpose. Both the data and the products can be divided into operational data, those which are produced in real time, here and now, and non-operational data, so produced later. Insofar as operational data, this is the measurement data and forecasts of the state of water, level of water, and the flow of water. Non-operational are the warnings, for instance, forecasts and characteristics. Among the operational products, very important place here is for our hydrological forecasts and warnings, and insofar and alerts, and insofar as non-operational, this is mostly for analysis and designing and papers, reports, and also including restoration measures. You might be also scared by this slide, but this is nothing difficult. This is about processing of the data. In order to use the data, you need to have them verified initially. First of all, we need to collect it in the field. You went to field workshops today, so I'm not going to concentrate on that because you've learned about the methods of collecting data, measuring data. The hydrologists for sure told you about it in detail. Afterwards, there is the transfer of data to our database, and it's saved there. Afterwards, they are verified operationally, and based on that, we get operational data which is verified, and they undergo more in-depth verification, more complex verification, and longer or long sections of data, and we verify historical data which are again saved to the database, and based on that we have historical data. Afterwards, they are distributed, they are shared, sent or given to the users, but going back to operational data, which is used for modeling, operational, hydrological and hydraulic modeling. Additionally, there is forecasting data, numeric models of weather, numerical weather models, and based on that there are warnings, alerts, messages, bulletins prepared. And this is the area of Poland. These are the sensors of the level of water. So the purple color are the stations with telemetrics. So we have data available every 10 minutes in our institute in a database. I'm not going to concentrate on this slide either, because all that was discussed today during workshops, how this data is collected. The next product is the modeling data. In order to get a forecast of the level of water, state of water, and the flow of water. There's hydrological and hydraulic modeling system, and the hydrological modeling system uses the data, the weather data, and there is the hydrodynamic HD system, and how this can be used, how data and products can be used, or rather more products with the use of modeling. There are the whole scenarios, hydrological scenarios prepared, and this is going to be discussed later by Director Przygrodzki. Besides modeling data, here I've mentioned the communications or messages, bulletins, all those characteristics are published in our everyday or daily hydrological bulletins. The current hydrological situation is described, and the forecasted situation is described, and based on those forecasts, model forecasts, there are also weather forecasts prepared, and also warnings insofar as flooding and drought. So now I move to non-operational data and products, those that are being used for planning and monitoring restoration measures. Based on the current and later daily, monthly, half-yearly, annual, there are those, the first level characteristics and then characteristics of the second level of several second grade. So we have a curve here of the flow, so the relationship between the state and the flow, and based on that we can make some assumptions, because only the state of water is measured at the stations. On the right side, you can see the example of a table of flow where we have collected the data, non-operational data, and where the data is available. The data that I just talked about. Operational data. First of all, during the period of hydrological threat or risk, have to be accessible very quickly. They have to be very transparent, and those challenges are overcome by our service, hydro.imgw.pl, where you can get this data. You can track it, and you can use the data. Of course, there are other channels through which we share the data. Through the app, a special app, there is AFD system, application SHRP, emails, FTP servers, and also the website danepubliczne.imgw.pl. Insofar as restoration and planning of the restoration measures, restoration, rewilding is happening in the conditions of water circulations and changes in the flow of water in the riverbed. So we can see it in the changes of the characteristics in the river regime, and this is mirrored in the changes of hydrological characteristics. So on one hand, restoration is the stage of planning, and what changes will result from restoration. And on the other hand, based on modeling and various scenarios, we can define what monitoring state will look like, what effects from the restoration we can obtain. And here, I've added a very hypothetical example. Let's assume that there will be a growth of retention in the catchment, and what on hydrological data, how we can watch or observe this change on hydrological data. I've used hydrograms of the input situation, so before and post restoration measures, and if we were looking at or verifying flooding, then after the implementation of restoration, we should observe a smaller peak discharge. This wave should be smaller, a longer time for the wave to go up, and also during low level, they should be milder and smaller deficit of water. There should be seen. Less warnings, less alerts for a shorter time, and also we should be able to publish alerts earlier. And what I've said at the beginning, how careful we need to be when we approach it, and what factors impact the detectability of the hydrological effect if we take into consideration hydrological data. The river regime, which is the result of many factors, hydrological information in a hydrological station is a synthesis of all the processes that are happening in a river catchment. So this can be a challenge to divide other factors that impact the flow from restoration. For example, such a factor can be a dominating climate factor. Another the thing is representativeness and the transfer of information. Well, the monitoring station should be representative of the area undergoing restoration. If they cover a large, diverse catchment area, the effect may be masked by runoff from the rest of the catchment, and this effect will not be visible. Quite simply, the same is resolution of the data and the significance of reference conditions, string length and data quality. They have to have this uniform string uninterrupted in order not to have changes in measurement. And ladies and gentlemen, this hydrological impact not always is the key factor, and we have to be aware that if hydrological data will not help us in detecting restoration that was introduced, then we need to know which data we have used and if we've used them correctly. And this hydrological impact is not always visible. And it doesn't mean necessarily that restoration measures are simply undetectable, but there is another factor maybe that might have impacted this situation. Thank you very much.
Dziękuję bardzo i bardzo proszę od razu o płyn. Okay, so thank you very much. We have a question in the chat window, and the director will answer it because it's a question about water levels. Hello and welcome, Joanna Depta. I'll try to present work of my center. We are identifying spatial range. These are activities in which we see potential that may be used in restoration activities. While my presentation lasts, I'm going to focus on the key topic on spatial range of flood plains, and this is going to account for most of my presentation. I'll try to communicate ranges, historic ranges that we've observed in the past, and later I'll switch to ranges recreated by hydro modeling, and later I'll briefly comment on the monitoring and forecasting along sections of the embankment. So we are monitoring water table versus ordinates, the base and the crest of the embankment. So first of all, like I've said, we identify ranges in a historical sense, interpreted as recent events, and for years we've been working on initial flood risk assessment, and ranges are assessed on very different sources and on the basis of surveys, media releases. So such estimates are less accurate, of course, and first data go to 1940s, and in recent years we've been also using and tapping into new opportunities because our ranges now are based on satellite imagining. So we have Copernicus Sentinel data, which is open data, and this is Sentinel-1, which features optical data. And while the flood or during cloudy weather, the image is not very clear. So in addition to assessing the risk of flood, we are cooperating with the Polish Academy of Sciences, Institute of Space Studies, and we have high-resolution images from ICESat satellites. We've had very spectacular cooperation during the flood of 2024 when we were talking to the Space Center about projections. Then came the flood, and thanks to our cooperation, we received access to their data, and they are now deposited in our database. During two floods in the summer of 2025, we received ready-to-use ranges. So this is high-resolution imagining, which is invaluable for us. It registers everything that is happening, and when we are doing comparisons, it can serve as a point of reference. We can also use it to generate the possible range of flood, and they're also used for gauging because we are generating flood ranges based on modeling, which is based on data discussed by Małgosia. And first of all, we have different types of modeling, and one of modeling types is taking into consideration annual possible accidents probability. So this helps us predict the risk of flood. And of course, we can take different probabilities into consideration. I've used the example of sites where high water, whose probability accounts for 1%, it shows very clearly that these are wide valleys the river would like to reuse again, and this is confirmed by the flood time. So we are also generating possible scenarios of destruction of flood embankments, and this scenario becomes even more probable. We can see old river bends, so these are the flooded terraces of the river. The second type of modeling we do, and we also generate and pinpoint potential flooded areas, and these are models based on operating model projections. We are showing the flood range along different sections of the river. And the model is up and running all week long. It's updated every 3 hours, and based on these results, we generate in real time potential flooded sites, and we have such maps for the city of Kraków, for the city of Warsaw, and now the project is extended for the entire Poland, which is covered by the Polish gorging network. Similar analyses are conducted for different model types, which take into consideration propagation of floodways as a result of destruction of embankments. So such models are put together by teams, and we are waiting for a potential risk of flood, and if it happens, we have ready-to-use models to use to generate such sites and alert the local population. And they also show areas of potential risk which may be flooded by the river. And the last modeling type, we also have simulated models. So we are relying on our experience to develop a model, and we can assume any conditions in a given catchment area. For example, we can create a model of a historic flood. This is Moryciny and the flood from the autumn of 2024. So the peak flood has gone through the area, and you can see ramification, but we can also use imaginary floods, not actual floods, to see how a given polder, how a given site or zone will be affected by the flood when the embankment is washed down or removed, and how a given section of the river will look like after the flood. This gives us data for further analysis. For example, we can recreate water accumulated outside the this is a slide from a presentation we've put together for Ilona, so you might have seen it in the past. We used ranges from ISI satellites. We have used data from the Polish network of gorging station, and another step is the ability to estimate the volume of water accumulated at selected sites. And you can see an example in this table and on drawings, because you should focus on the scale we are talking about. For example, just a moment ago, I visited this beautiful white and green manor site where you have an exhibition of photographs, and I saw a photograph of a desert, but there was no scale. So it could have been something small or large. This is Racibórz Dolny Reservoir and its volume versus natural range, the same reservoir in Kostrzyn on River Oder. And based on these ranges, you can project the capacity of infrastructure located in a given area, so you can compare sites that you can try to plan. You can also try to plan restoration or maintenance of valuable natural sites. So flood is an opportunity to identify sites for water retention. What may be helpful for in restoration activities, for example, restoring the river channel, building alternative channels, or restoring the original width of the channel. And another byproduct, when we were working on the flood zones for the operating model, the monitoring and forecasting sections of embankments in terms of the embankment basin crest. And we'll be very happy if someone will benefit from this model in your research. We covered more than 5,000 kilometers of embankments in Poland, and we have created a map with 5 degree scale. Level 1, there is no risk. Level 0, there is no risk. Level 1, the water level reaches the base of the embankment. Level 2, you have water level between the base and the crest of the embankment. The red level, you can see the table of water between halfway through the base and the crest of the embankment, and level 4, the most dangerous one, when we project that water may overspill. So this model is available on our website for registered users, so emergency services only, and you have the timeline of 72 hours, and it's updated all week long, 7 hours a week, 24/7. And as you can see, this model can be used in ongoing monitoring of embankments, and you can also go back in time. You can conduct historical analysis. Right now you have a span of only 18 months, but it's a ready-to-use tool that may be used to identify sites where you have a recurring flood risk. And it might be a suggestion that this is where restoration is advisable. You can also analyze variance, like with simulation. You can suggest a specific situation in the catchment area and see how it's going to be reflected in face of flood. So to sum up, I wanted to demonstrate that we have the expertise and the tools to identify the range of flood and to analyze it and analyze sites in terms of risk. We are using data from our own gorging network in different models, and we have resources that we believe can be used in planning and implementation and assessment of restoration initiatives. Thank you very much. Okay, I'm coming back to wrap up the session. Okay, so thank you very much. In the chat window, we have a question, so I'm going to read it, and let me read it out. There is a question, why emergencies and alerts are related only to high water. Can we have similar alerts when water level is extremely low? So the level of water alert used to signal low level of water is not a good idea, because in most rivers in Poland, those rivers are overgrown by vegetation when it's warm, and then very often when vegetation grows, the level of water increases. So that's why at my institute we're using flows. We are relying on the median flow value, SNQ, and we are comparing it to the current flow. So it's not a matter of achieving the SMQ value, and that's how we send alerts against hydrological drought. So, so this is the consensual flow that is used in the context of water shortage. Okay, so that was my response to the chat question, and let me proceed with presentation. I have put together for you. So the use of modeling for assessment of restoration activities. Several aspects have been discussed in our discussion before in previous presentations, and
So far, as the use of modeling for the assessment, not only for assessment, but also for forecasting and hydrological warnings, alerts for the support related to restoration. The key here is data which is used in the models. And we use hydrological data, we use also meteorological data, and of course we use models for that. And these models are created, are done for the needs of hydrological analysis, for restoration measures, are related to three aspects, basic aspects. The diagnosis, so defining the situation at the beginning, planning and designing, so looking at single measures, investments, and of course afterwards monitoring. Insofar as the models which are being used for this objective, these are models within river threats or risks, so like the models discussed by my colleague, rainfall, outfall, and hydrological models, which are used for the upper parts of the catchment. They are put in a hydraulic model. The current model is working for about 10,000 kilometers of rivers. As I've said, this is calculated every day on a daily basis, actually seven times per day. Of course, we have also maritime models, two-dimensional models. We are working on a very important component related to hydrological threat, related to floods. This is being right now developed, and we hope that it's going to be implemented in 2027. All models that function in the Institute are developed on a current basis and calibrated, developed on an ongoing basis. Special significance in the context of modeling, if we are talking about hydrological or hydraulic modeling, especially hydraulic modeling has a special place because it has been used for many years in the Institute. It is based on a proprietary solution developed for many years. This is one dimensional model which is based on Saint Venant's system of equations, and it's primarily used to focus water levels and flow rates. Its scope is quite developed, and the basic assets of this model, benefits of this model is very quick time for calculations, and it's very easy to check the entire area of Poland, the possibility of development, the compatibility with PSHM systems, and ongoing calibration of results. When we're talking about this model, very important part of this model is the cross-sections database. So within this model, the Institute has a cross-sections database for about over 600 rivers, and currently in this database we have over 55,000 cross-sections, which of course are being used on an everyday basis for modeling. All right, so we know that for the goal of operational modeling and for the needs of analysis and for supporting restoration measures, we use models, especially for river threats. We have the model precipitation, or rather rainfall, outfall, and other models. And now I would like to talk about a flood risk reduction program, which was created together with Wody Polskie, Polish Waters, and Polish State Institute, the Institute of Meteorology and Water Management. And there was a project analysis within this project of individual investments that were included in the programs of planned investments of Wody Polskie, Polish Waters, but also, luckily, in those programs there was space, there was an area to point to potential possibilities or opportunities for measures based on nature-based solutions, NBS. The Institute within these works took care of the assessment of the effectiveness of flood control investments and solutions using hydrological and hydraulic modeling. Insofar as the scheme or the sequence of developing these programs, first of all, at the first stage we had the first plan according to the findings of Polish Waters, Wody Polskie. Afterwards, there was social consultations and local government consultations, and currently we are undergoing the works on the final scope of those programs. The majority of those programs for individual rivers that you can see on the right side has been already developed. We still need to do those works for two rivers, the river Olza and the river Osso-Błogi. So what was the method of the works? I would like to remind you that the task of the Institute was to assess the investments and the measures using the modeling platform. The basic rule or assumption was modeling using data, meteorological and hydrological data from the September 2024 flood. For this, precipitation data was used, precipitation data which is called here RE-NATURA. This is an institute product, this is maybe interesting for you, which defines precipitation not only in single measurement points at the meteorological stations, but it allows to figure out what was precipitation or rainfall in between the stations. So define the rainfall in a given area. And this acronym GRS means that this is ground, radar, and satellite data used. And the combination of these three elements gives us the form of this spatial rainfall, spatial precipitation. So this data, besides thermal data, hydrologic data, this data was used in the models, in the rainfall runoff models, which were, of course, there were the right parameters introduced there based on the calculations in the models rainfall runoff. There are hydrograms created, which were these presented the conditions for the hydrodynamic model. Within those models, both hydrological and hydraulic model, there were anti-flood solutions included. As I've said, luckily there was space for NBS, nature-based solutions. There were simulation calculations done, and the last thing was the analysis of both models. And now, ladies and gentlemen, the right part of my presentation. So possible applications of hydrological and hydraulic modeling of our institute in the evaluation of the effectiveness of restoration measures. I'm going to present to you the results of modeling for two catchments. The first catchment is the catchment of Olza River, Polza River catchment area, which is a cross-border river. It has a source in Poland, then it goes to Czechia, to Czech Republic, and afterwards it becomes a cross-border river. Again, it goes back to the Czech Republic, and again it returns to Poland, and this is a tributary to Oder River. Above Racibórz is reservoir. You can see all the numbers on the slide, how much of the catchment is in the territory of Poland. And within modeling, two options were developed for potential increase of the retention of the catchment, both on Polish and Czech part. We've done it only for Poland. It was not sufficient, so we've decided also to include the Czech Republic. And within modeling, there were possibilities presented for retention, both for natural retention, forest retention, the change of in agriculture. So all possibilities. It was not precise which solutions would be undertaken, but there was a whole catalog of possibilities listed. Two options were actually launched. In the first option, there was additional retention and
kwadratowe. I tu mamy wyniki.
And here we have results, and actually I'm going to say that these results will be presented to you in two stations. This is going to be Cieszyn station in the middle side of the catchment, and at the mouth in Łaziska. So this is the first station, the results for the first station. The Cieszyn gauging station, there is a hydrogram, and you can see on axis the terrain and the period of floods in 2024. In black we have marked whatever really happened in 2024, in red the results of option 1, and in blue the results of option 2. And for Cieszyn gauging station, this reduction is quite significant, because for option 1 we have in the peak flow about 55 centimeters less of water, while in option 2 this is over 1 meter less. Similarly for Łaziska water gauge station, gauging station, here we have 13 centimeters for option 1, and for option 2 26 centimeters. This is the amount of reduction. The same analysis or similar analysis was done for Bystrzyca catchment, which is a tributary of Oder River in Wrocław, right below the center of Wrocław city. The length of the river 103 kilometers, the surface over 1,700 square kilometers. Insofar as the assumptions, they were identical compared to the catchment of Olza River. This was on purpose, that we assumed the same assumptions to identify possible differences. The analyses were carried out or presented, or will be presented, for 3 stations. 2 in Piława tributaries, and 1 in the station on Bystrzyca. This is in Kraków. In general, within modeling of Bystrzyca, we took care of the upper catchment below one of the reservoirs. This is why it was decided that this section below is protected by the Mietków reservoir. So these are the results. This is the hydrogram for the first gauging station in Dzierżoniów, on Piława, in Bystrzyca. This is 11 centimeters less for option 1, and option 2 24 centimeters less in the peak wave. In Mościsko precipitation 10 centimeters less under scenario 1 and 19 centimeters less in scenario 2. And the last gauging station next to Mietków on Bystrzyca, option 1, 8 centimeters less, and option 2, 16 centimeters less. So, ladies and gentlemen, this is my last slide, which is a conclusion of those results. So, for sure, it should be stated that these results and the works that I have presented to you have shown that it's possible to use modeling, hydrological or hydraulic modeling, for specifying the direction of activities, of measures, and significance of those measures in the context of improving hydrological safety of a given area. For sure, these results, which were presented, can show the proportion of reduction to the scale of necessary measures in order to increase retention, taking into account natural retention forms. At the same time, we need to take into consideration the fact that natural retention is less effective for extremely high floods, and it decreases in the event of rainfall preceding the main flood. The extent of the reduction that I was talking about is also varied. On some rivers, it brings about very good effects, on others a bit worse. So the conclusion appears that this significance or the impact on hydrological safety is directly dependent on local geographical conditions in a given catchment area, and these conditions also determine what activities, what measures we can undertake in a given catchment area. And I think that the obvious and trivial conclusion, but the results presented here indicate that an appropriate approach to spatial planning within the catchment area can help to improve flood safety. This is all. Thank you very much.
Bardzo dziękuję.
Thank you for those presentations. Since you've started, please also summarize and finish this session for us. Is this time for questions now? Ladies and gentlemen, such a description in the form of an anecdote. Is it worth to use gauging stations data which is shared by IMGW? The situation is the following. Yesterday I showed the film from some intervention. There were 3 meters of water. We are looking on the gauging at the gauge. The water goes down by 3 meters. Gradually it goes up because the lower position or station is flooded, and I leave the closures as they were on the film and I go home. I had a hunch, and I'm looking that the flow is growing excessively in Przechody. I'm at home, I'm going to sleep, I wake up in the morning, it's growing. I couldn't take it. I came from Warsaw to Grajewo, and I'm driving as fast as possible. And it turned out that what happened? The old riverbed, Bobrowe, found its path to the old culvert through the Kowasy Canal. This water returned to Rudzki Canal, and it was beautiful how it showed this half a meter of difference, that I was so afraid that there would be something leaking, and maybe too much water, excessive water can go through, and there could be some flooding. So I congratulate you on this material that can be used. And this is the first thing. And the second thing, it's a suggestion because this was a really great idea to, insofar as those embankments or dikes, but how much is it in accordance to some provisions on hydrotechnical solutions? Because it says that you can go as high as you calculate the probability. You should look into the book, Wały Warszawskie, Warsaw embankments or Warsaw dikes, and we've done similar works there for Warsaw, taking into account those different flows for different types of levees. Maybe it's worth to look at it, to check how it was done. Before you answer this question, I understand that your question about growing flow was about growing level, yeah, of water on the gauge, yes? Well, just one word in the context of this product and the risk of going over the crest of the embankment. Quite a new product that you've heard about. For now, this product actually defines how water currently and in the forecast is being shaped. What is the water table insofar as the crest and the shape of water. So there is no information about embankment safety. This is in the plan. Actually, there are some comments of Mike.
To jest w planie, żeby te informacje też powiązać, bo bardzo istotną rzecz Pan wskazał, że to, jak woda jest ułożona względem wału, to jest bardzo ważna informacja, ale nie jedyna, która warunkuje zagrożenie, bo jeżeli wał jest słabej klasy, nie jest stabilny, no to może to powodować zagrożenie, niekoniecznie jak już woda jest przy koronie, tylko znacznie niżej.
To znaczy, jeżeli mogę, ta klasa wału ma bardzo ważne znaczenie moim zdaniem, dlatego że jeżeli byśmy wszystkie wały zbudowali na klasę pierwszą, no to tak samo chroniona byłaby Warszawa jak obszary mniej ważne. Dlatego ja wskazywałbym te klasy, dlatego że one są też ważną informacją operacyjną, gdzie może dojść do przelania i to powinno być w jakiś sposób akceptowane społecznie też, że my nie jesteśmy tak naprawdę chronieni w pewnym zakresie. Także nie wiem, czy to jest taka wiedza, która powinna być ogólnie dostępna, na pewno tym, którzy dysponują możliwościami, powinna być udostępniona.
Jeśli mogę jednym zdaniem się jeszcze odnieść, dziękuję za tę uwagę. Tak jakby idea tego produktu była troszkę inna. On ma nam też pokazywać, kiedy my na przykład mamy być w gotowości z uruchomieniem naszych tych modeli przelania przez na przykład wał przeciwpowodziowy, nie? Czyli jak my widzimy, że gdzieś tam już podchodzi pod koronę wału, to my możemy być w gotowości z kolejnymi modelami. Natomiast jest jeszcze jeden problem, że my tak naprawdę poszukiwaliśmy i w Polsce nie znaleźliśmy jednorodnej bazy danych przestrzennych o wałach, która mówiłaby w jednoznaczny sposób, który wał ma jaką klasę. I tak naprawdę wciąż siedzimy w tym temacie, ten produkt, jakby pracujemy też cały czas nad tym produktem, ale problem jest z dotarciem do tych danych. Te dane opracowaliśmy w zasadzie sami, tak roboczo, na podstawie numerycznego modelu terenu, czyli sami określaliśmy rzędną stopy i koronę wału, żeby móc sobie wygenerować jakby to zagrożenie. Natomiast oczywiście to, o czym mówi pan profesor, jest takim tematem trochę obok, a niekoniecznie mamy też do niego dane wejściowe na ten moment. Dziękuję.
Tak, to przy zastrzeżeniu, że oczywiście klasa wału to jest jakby podstawową informacją projektową, tak? Bo tu musimy odróżnić ten element, aspekt projektowy jako projektanci bez pojęcia klasy wału nie mamy od czego zaczynać w ogóle tematu wałów. Natomiast tu jest kwestia bardziej obserwacji i takiej operacyjności osłonowej. To już tak stawiając kropkę w tej dyskusji, żeby nie odbiec za bardzo od renatury w tym wszystkim. Ja tylko jednym zdaniem chciałbym zakończyć. Szanowni Państwo...
A można jeszcze pytanie?
Jasne?
Tu, na końcu.
Dobra.
Jacek Zalewski. We always guys want to apply models created for rivers, check our activities and ask the manager for information about what activities may be implemented. And recently, in collaboration with Polish Waters, we have asked them for a model. We tried and tested it and later discussed it. The question is how flood risk plans managed and updated by Polish Waters compared to your efforts and work. What is made available? Are you working on the same cross-sections, on the same models, on macro scale? Because I have a sense that we have an excess of model data compared to restoration. It's a massive effort. Probably if we implemented those data and used them in real life, floods would become a scarce sight. There are two aspects to your questions. What's the input data and is it identical? So let me start with question 2. Models are different because you can't use the same model for everything. Also because our models, the ones I was showing you, have been adopted to do back analysis. They must be operational. What do I mean by operational? They must be accurate and precise, and they must provide answers very fast. They need to be countable in real time. So that's the fundamental feature of models we are using. So models are used by the Polish gorging service. Computation is instant, while models used by Polish Waters, by Polish water authorities to update the flood risk and update flood risk mitigation plans, this aspect of time is not relevant. So application of both models is exclusive, simple as that. And input data, we are using the same input data. So these are longitudinal cross sections which we receive while updating plans and strategies from Polish Waters. We also obtain data related to model maintenance, maintenance of models for gorging stations, and that's how we receive this data. Of course, we calibrate models in real time, and we also update coefficients to ensure that calibration stays up to date. And as a service, we gorge cross sections at gorging stations, and this figure is regularly updated. And this information is also used in our models. So nothing changes our procedure, because we are an outside stakeholders in relation to the Institute. We are still seeking for basic data, for raw data, which is provided by Polish Waters, yes. So I want to believe that this is different data, different raw data, and there is a different needs that dictates that such data is used. So this is our basic raw data that we are using. I know it very well. They assess distinctive parameters. They're provided under regulations. They have an impact on areas exposed to the risk of flood, and the Institute's models, well, we implement them to provide protection. They are updated here and now to react to all impending threats. And designing-wise, designing is based on probable flows, and we're using data provided by Polish Waters. Okay, so on a final note, unless there is another question from the floor, because I don't want to say for the fourth time running that I'm coming to an end. Okay, I just wanted to draw your attention to the fact that we've had our experts from the institute responsible for hydrological protection of the country, which in minds of most citizens is associated with protection against floods. That's your first instinct. And I think that data we have, the repository of knowledge, I think it indicates that we are focusing equally on drought. Why? Because those risks are equally important, and we can see it very clearly, and it's going to become a more frequent sight. So we are protecting Poland against drought and flood. And the Institute is not project-based. We are not focused on projects, while protection is meant to provide reliable data and imagining that can be used for further conclusions, and we are collaborating with Polish Waters and the wide public. We are also communicating with the Polish society using multiple tools. All the tools that were discussed today were designed to address a need during an emergency. For example, some data were missing, and that's why we keep on introducing and implementing new concepts all the time. We are implementing new tools because new risks are appearing dynamically, and we need to be able to respond adequately. So all those tools are in development all the time. For example, the tool you've asked about, it's in the pipeline. We have a vision, but not everything can be done at the same time. Thank you very much. So this is the end with a slight delay. But we are not having a fixed timeline. I think it's a natural thing. After all, we are talking about restoration. So what do we gauge? We discussed metering and gauging. Tomasz Krepski, who's left, Małgorzata Gori, Małgorzata Gori, Joanna Depta and Paweł Przygrodzki. I would like to invite you for a break. Perhaps let's take a 20-minute break and let's come again 5:15, and after the next session, which will be a discussion. We are going to have a discussion on restoration, about what restoration is and what it isn't. Is it a regulation? Is it engineering of the river or not? We'll start the discussion, and later we are going to be carried by the flow to Hyde Park, and we'll finish when we are kicked out of here. So 5:15, we are coming back, and I would like to thank all the speakers. Bravo. Szanowni Państwo, ladies and gentlemen, even herons are being late, and our speakers are late. I don't know, perhaps he's so tired after previous sessions, he didn't make it here. Szanowni Państwo, welcome after the break. The session Engineering versus Restorations, and taking center stage is Professor Zbigniew Popek, Professor Emeritus of Warsaw Academy of Life Science, and Tomasz Okruszko, Professor of Warsaw University of Life Sciences, versus practitioners Maciej Chomiczewski of the Institute of Meteorology and Water Management and Wojciech Dzietczyk. We are going to invite Zbigniew Popek first and later the second professor with his presentation. Good afternoon. Perhaps I'll have a slow start to wait for latecomers, but on the other hand, how do I start and open the presentation? Can we have Zbigniew Popek's presentation so the professor can click over to his slides? My presentation is missing, isn't it? I've sent it. Okay, so the professor has a pen drive. Okay, he is an experienced speaker, and save for the fact that we are trying to do everything to very high standards, but as it transpires, there are certain things that got out of hand and that we should improve. Okay, so a standard flash drive is better than we transfer technology and other methods of data transfer. Oh, I'm lucky that I've got the USB drive. Okay, so we have the presentation, you've saved the date, and you've saved your own session. Okay, it's not the first conference I've attended, so I know how it works and how we can end up sometimes. Okay, so I'm going to address a challenging topic because I have limited time and I need to discuss quickly very fundamental morphological characteristics and terms and conditions for shaping the morphology of riverbeds. So let's get going. I'm not going to read those bullet points which will appear on subsequent slides, and I'm going to limit myself to discussing the morphology of alluvial rivers because this is the dominant morphological type in Poland. Okay, so alluvial rivers are rivers which are formed in loose, sandy and gravel beds, and because the substrate is loose, they are moving together with the water flow. So they are moving downstream as debris, sediments, which is dragged. That means that it's in contact with the bed or periodically in contact with the riverbed. And there are also finer particles which are floating. So let's start with the physics side of the river. We have a bed which is recreated in a lab. And we have added sand of adequate granularity to the bed. What is adequate granularity? It's granularity with fine particles which are not floating but are carried downstream. They are dragged along the bottom of the river, and what do we see? Sometime later we see a winding stream. And what is formed at the time, or what is changed at the time, is the line of the current. Without sediments, we would have in the axis, we would have the dynamic line of the current, so we would have the biggest velocity at this point. But since sediments are dragged, the current begins to meander down the riverbed. So it's shifting from one side to another one. So it's winding its way along the axis of dragging. And this photograph shows the longitudinal cross-section. So this is a phase of sediment movement after long-lasting flow. Because on this photograph, what we see the movement on the riverbed called wrinkles. So these are tiny waves, undulating waves of sand of minor length, and if there is a thicker layer of debris and if the velocity of current is higher, such wrinkles are being formed. We can see bigger lengths and widths of the sediment, and there is an in-between stage where you can have wrinkles on undulating waves and folds. On this photograph, at this stage, the bed is not aligned to the water table. There are hollows and we have riffles. And another feature, so the bed load, if it's natural, grains are big and small of different values, and because whenever you have shallow water, velocity is higher. We see coarser material, coarser particles exposed because finer particles are carried downstream. And when velocity goes down, we see finer particles accumulated at the top. So in other words, introduction of such bed load, even in perfect conditions like those recreated in a lab, we have a still river bed, we have smooth bed walls which are rectangular. Even in such conditions, the river is forming a bed of its sorts. So introduction of the load plays the pivotal role in shaping habitats, in shaping microhabitats, because what I've said at the beginning, we have diversified location of the current, of the line of the current. In standard conditions, we would have erosion of river banks, which would take a more winding course. So this is one variable. And the second variable is the longitudinal profile of the river, a place with greater and lower velocity and related depth parameters, and we have diversified grains of particles. So there is a number of morphological parameters that comes into play, a number of variables, what leads to establishment and created of microhabitats with different microbiotic conditions, what translates into habitat variability, and as a result, the biodiversity of species, the biodiversity of living organisms dwelling in rivers. And such river, I've managed to capture and observe such river in a park, on a path, on a park alley which was covered in sand in winter, and that's why a thick layer of sediment was accumulated, and it was moved by melting snow. The alley is covered with tarmac, it's smooth, but you can see that the water is not flowing is not running off in a straight line. We have morphological shapes being formed on its surface, and you can see wrinkles very clearly. And this is another photograph. It's a pond which has been drained, water has been evacuated, so the rivulet, a natural rivulet that feeds the pond, has formed a bed, a winding bed, and not a straight line from the inlet to the outlet with some sort of a watershed. So variability, morphological variability is natural. The fact that rivers are taking such course, this is the after effect of physics. You can't force anything. And even if we do engineering the river sooner or later, and this is an engineered section of the river by itself is going to change the course, is going to divert from its bed because of the layer of the sediment, the volume of the bed load, the velocity, the volume of water passing through different sections. And of course, when you have a straight line bed, it doesn't mean it's been engineered, because in this case, for example, it's totally natural. It's a valley, but it's a winding valley. There is no floodplains around it. You have just slight extensions of the riverbed, and this is also natural. The bed with steep banks is typical for big waters. Big waters should be flowing in the simplest bed possible unless there is a floodplain around it. Where mid and low waters will always have a tendency to meander. Okay, so why is it so? Why do rivers take a winding road, a winding course? This is because of physics. But in real life, when we are talking about shaping riverbeds, we need some rules, we need laws. And the first man who began to seriously analyze rivers was a French engineer, Mr. Fargue, who was active in the late 19th century. He died in 1910, so quite a long time ago. And he formulated a number of laws which are now 100 years old. And in case of river engineering, his laws are not widely applied in our country, not only in Poland, by the way. I'm going to discuss it in a moment, but Farge law says it's the law of arch length, which says that arches are stable if their length is optimal, what is distinctive for a given river. So it's not very precise, is it, as a law? But it means that change in morphology and the shape of arches results from characteristics of a given river. What happens if arches are too small? I'm talking about length. The river begins to extend its length by erosion of convex and concave banks, so the river is moving. On the other hand, if the length is too big, usually the river would move its current, like I've demonstrated, showing you the photograph of the lab recreated riverbed, and the convex bank begins to erode, and the longer arch is transformed into three shorter ones, which are typical for a given river. The second law, with longitudinal current, the second law provides that the profile is regular if the curve of the arch is changed continuously. So a sudden change in the curve results in a sudden change in the depth. What does it mean in real life? Well, it means that the curve, or the opposite of a radius, I should explain what RO means. R is the radius of the arch, so the curve changes continuously, just like the sinus function. And this diagram reminds us of this function. And because the curve is changing, the profile of the bed will be changing too. It will be regular, but it will be changing continuously. It will have deeper sections, more shallow ones as well, next to the next arch, and shallow ones again. And another law. Oh no, this is the description of an arch. So those deeper pools or hollows are known as pools. And between them we have riffles, or those deeper sites where current is rapid, because this is the place where the current is running in the middle, in the center of the bed, and later crosses to the opposite bank. And the distance between subsequent pools, and this results from the length of the arch, it's fair to say that they are almost stable in terms of proportions versus the width of the bed. So from 5 to 7 units in width. So each and every river, even the smallest one, is a model of a bigger one. Because, for example, if a bed is 1 meter wide, then on average the next pool will be from 7 to 5 meters long. And if the river is longer, it will be from 50 to 70 meters long, and you can compute it for each and every river, the proportion, which will be identical. And of course, this is not a very strict science, because we've said before that the length of arches is typical for a given river, so that means that you need to check beforehand. How does it look like in this particular case? So this horizontal layout of rivers, if it's natural, then it's usually stable. Of course, you have sites where erosion is appearing, and you can evaluate it very effectively on the basis of orthophoto maps overlaid with land survey maps. This river is flowing somewhere in Podlasie region. I don't know where exactly. It was engineered back in the 1970s, and the photograph was taken recently. So 50 years on, approximately 50 years on, you can see that the boundaries, that the line basically overlaps with the limits of the river. There are only isolated sites where you have minor diversions. And what is happening in the regulated section, you can see that in some sites, in some places, the bed has diverted from the engineered riverbed and its limit, because you can see that it has been altered artificially by man. And the riverbed has been dug up, and it does not overlap with the natural course of the river. So you can compare it with unengineered section. And this is a large river, the Vistula River. I've said before that forex laws are not widely applied in engineering and design. Why? Because they are quite challenging in practical application. First of all, they require previous pre-implementation tests. You need to survey, you need to research morphological properties of the river, and secondly, this curve of arches, application of curves with variable curves, of arches with variable curve is not easy. For example, the parabole, the spiral at every point of the arch, you would have to measure the radius, which is changing, which is different, which is why for a designer, it's a daunting exercise. Of course, it's doable, and there are examples where it went quite well. But this example of the lower Vistula River is an example of German engineering, and Germans took a shortcut. They were using circular arches where the radius is stable. So if we overlay the course of the curve on the graph illustrating changes in the riverbed, which resembles a sinusoid line, we would have a line parallel to the axis, x-axis, then a rapid diversion, and the curve is changing not continuously, but suddenly, abruptly. And this is the effect, and as a result, the bottom profile is hardly predictable. And on the top of that, Germans never took into consideration the length of arches. So in Vistula River, arches and radiuses are too large, and as a result, you don't have the current running along the concave line of the riverbanks. You have riffles in different places of the river. You have hollows, and cross sections of the river are too wide, and as a result, the navigable way is quite a challenge, because you need to sail, you need to navigate, not like the Germans predicted, or like Farag designed his guidelines for. Farag was formulating his laws to make French rivers navigable, and you can track. In modern times, I checked it myself, rivers which were engineered in Farag's time, you can check what is the shape of French rivers. They are meandering, perhaps they are still navigable, although inland boats are becoming a rare sight, but the river is stable, unlike what is happening in the lower section of the Vistula River. Sand spits look spectacular, but for example, you have mounting ice in the winter, and the risk of floods is looming large because the capacity of the bed is limited, and the river is hardly navigable. So you can see that for this section of the river Vistula, we should have shorter arches with smaller length and smaller radiuses. You can also see it on the physical model of the river Vistula. Such model has been created by the now defunct lab of Hydroprojekt based in Włocławek. So we have recreated a section of the river Vistula, which in natural state is 15 kilometers long, together with existing groins, and we have obtained a very realistic image of the river. So the current is stable. The current is being diverted from side to side. Sometimes mounds are created in unpredictable places, or deposits are created in unpredictable places together with pools. So, like I've said before, if we are altering the course of the river, trying to make it straight, if we make sure that no maintenance work will be performed, the river will change its course. The river will alter its bed, which will begin to take turns. And this is the best way for restoration. Leave the river alone. Don't mess with it. Or if you want to obtain such effect before, look where pools are located, where riffles are located, and perhaps then you will be able to increase the pool. For example, in places where banks are not watered down, you can improve, you can help the river take its natural course. We have recreated the river in a lab, and there is only sand on the bed of the river, but you can model, you can use different substrates, and it doesn't work like this in nature. You don't have a uniform substrate of the bed. Plus on the banks you have shrubs, you have vegetation, you have trees growing, so exposure to changes in the shape of the channel is also variable.
Więc proszę Państwa.
So, ladies and gentlemen, now the rules. I would like to discuss the rules of natural regulation, because this regulation, according to the German school, brought about great losses, because what was not taken into consideration is what Fogg did. So he studied how this morphology is being shaped in nature and how we could possibly correct these rivers.
One były stabilne.
So they're stable, because this is what we care about. This is also very important from the environmental point of view, for these conditions to be stable. Of course they change, because the river changes its flows. There's flooding. We are talking about the so-called dynamic stability. A physicist might be appalled. Well, stability, it means it doesn't move. If there is dynamic, there is movement. Well, yes, but a river will never be stable. There will be always the flow. There will be always the movement of the sediment. It is about this natural changeability, variability in the long term, which results from the fact that we have a different or changeable hydrological regime every year, or in multi-year approach. We have processes resulting from the conditions of the transport of riverbed, which also change because they depend on the flow. So another important factor is riparian vegetation, which is also changing according to the different stages or phases, phenology stages. So in many years that pass, trees are growing, shrubs are growing. So this also, it changes the resistance of the flow. So it impacts the hydrodynamic conditions. So this all should be taken into consideration. Also the FARG's rights or FARG's laws, and then the effect of the regulation will be completely different. Another important thing, what I've just said, that the process has a dynamic character, the channel forming process. But if these changes in the long term are such that the general parameters of the river are not changing, about the width of the channel, because as I've said, the banks can move, can shift, but it's not that one will move and the other one will keep standing in the same place, because when you have the bank without erosion, then well, it's going to look different. So we have the stable width, but not necessarily the channel is in the same place. So it depends with the concave and convex banks. But there is a gradient which is either stable or changeable, but the width, the depth, and the speed are in a similar scope or range of variability, and there is a balance or equilibrium between the flow and the bedload transport. So then we say that these rivers are dynamically stable. Professor, if I could ask you to come to the conclusion, these are the examples of the rivers that were regulated, taking into consideration FARG's laws, and Vistula, but the middle Vistula, Mr. Wierzbicki from the Warsaw Technical University has developed these parameters. And we see it, but we don't see it exactly, because there are some positions of some channel forms, some islands that are changing, but they keep staying in the same place. For example, in those sections. Similarly, insofar as those higher sections in the area of Natura 2000,
Cechy naturalne, odnawialne, chociaż
there are natural characteristics, but the route is moving, meandering, and the banks are quite stable. So this was Natura 2000 Vistula watershed. And this is all discussed by the FARG's law, this morphology of alluvial dynamically stable rivers. We have big problems because those transformations generate simply the necessity to perform various maintenance work, dredging like in the lower Vistula, and maintaining this water route. So if we're talking about restoration, first of all, we have to leave the river in peace, and then the restoration will be happening on its own. Or we should direct the works in such a way in order to accelerate the process, because sooner or later we will have such a situation that these laws will be binding. So this is all. Thank you very much.
Bardzo dziękuję. Też poprosimy pana profesora Okruszko. I tego tak słowo.
So we would like to thank you, the professor. This was a longer lecture introducing us to this discussion. We wanted to talk a little bit about this technique insofar as engineering and the scientific technique. So Thank you very much, Professor, for this wonderful presentation. And afterwards, after the presentation, we'll be speaking together with Wojciech Dziedczyk, and afterwards we'll have a discussion. You have watched for sure this presentation of Engineer Bartosik when the flow in the middle pool was going. We have counted the water balance for the middle pool, and we need to do something about it because 30 years have passed. So the recommendation for those who are working in restoration, well, it's like with health. Don't drink, don't smoke, for sure you'll encounter good effects, yes? Well, a little bit about upscaling. I'm sorry, this is an English language title proposed by the organizer, but this is about scaling up. But I hope that you'll be there with your practical reflections. This is not just a lecture, because when we were creating this law on the restoration of nature.
Część osób pewnie na sali z Waterlands, prawda, czuje blisko. Ja byłem w Merlinie.
I was in Merlin. I was creating this project, and I have a few thoughts. Because please pay attention to the fact that this scaling up is not only so we can make one project out of 5 small projects. So this is not only the geographical aspect, but this is about the creation of a new quality insofar as space and cooperating with all interested parties. It's not that these problems that we have with implementations are as they are. There was an excellent question during one of the workshops. Can we live in the world without projects? Can restoration happen without projects? But we develop cohesive long-term funding. And finally, since long-term,
Państwo to do siebie odniosą, to znaczy do swoich projektów, bo te dwa wykresy to jest pewne...
These two graphs is a certain type of proxy. We're asking about difficulties with getting information about measurements in order to calculate various types of criteria. And we have the temporal scale and spatial scale, and when it's purple, it seems we're not measuring too well, and green is good. So the closer one, environmental, are green, but when we enter social, God forbid, economic, it's even more difficult to implement it. So in the majority of cases, we have very good situation, but there is a threshold. The project will be successful or not, or it will last for a few years. It's not monitored as well, this process. So similarly here, there is a scale of effort, and here the scale of weight. On a smaller weight, there is this economic component, and we believe that these criteria, the Green Deal criteria, but as I've said, this is just a proxy. So we care about them. We believe that they are important, and very often we have a problem in this part here, and increasing this scale, this is very often a social and economic problem. So a certain collection of experiences from these projects insofar as upscaling. Look at the diagnosis of the system and those connections between social aspects and economic aspects. So the narratives of the future, I'm sorry because these are English documents translated by ChatGPT, so this doesn't all sound very well. The narratives of the future, in my opinion, one of the most important things if we want to do restoration on a bigger scale, restoration or rewilding, so it becomes fashionable, trendy. So it shouldn't be perceived like that there is just a group of aficionados who have this hobby, but they don't know much about reality, but that it's a process, socially important process, and we need such a narrative, not as some social trick, but it should be a social process, and I'm talking about it. I'm saying that it should be far away from that there should be not social understanding and acceptance only, but people should say, this is not a bad idea. I'm from the Warsaw Life Sciences University, and this is a question about certain identity, dignity, about how people function, and not just that they're tired of the city and they went to the countryside. Scientific foundation, resource management, and involving stakeholders. I think there were 18 in Merlin, and in others, I don't know how many. Number one were stakeholders, and I believe that the same thing results from your research. Those that didn't come, also they are also stakeholders, and how we can discuss it. How from the single projects that should be demonstrators and experimental field. This was a great session, learning on mistakes and what we have learned, because pay attention to the fact that the project system is punishing us for failures, but this is the only way to gain knowledge. How to break through the resistance in this area. This is one of the greatest challenges for those who are dealing with projects seriously, and we assume that this is gonna be successful on a larger scale in all dimensions. It was estimated. What's estimated? It's the means that should be paid. This is between 8 and 25 billion per year. F-35 is 4.5 billion, yeah? So we would have to buy 2 like that in Europe, and it would be the same. So comparing to the military world, the budget of Spanish army is 40 billion per year. So this is half of the Spanish army, and we have the money which is necessary. It's just to show you the scale. It's big, but it's not improbable, right? These numbers can be imagined, but this is a financial gap in Europe in order for these intents that are described with political documents to be implemented. This is the scale insofar as European funding, and of course from national funds. So what, well, a lot is happening. And with all those emotions that accompanied the introduction of the nature restoration law and plans related to it, so it was about what was the relationship between NR and PGW and how much they are in contradiction. Because we don't have this plan in time and space. There are differences. There is a different way of assessing, quantitative assessing, 25,000 kilometers of slowly flowing rivers, and different in the Water Framework Directive if we are striving to have a good environmental state, ecological state. And nevertheless, the path is cohesive. So recreation or restoration of free-flowing rivers is a necessary condition for some provisions of the Water Framework Directive. what's important, it should be the same money, especially because the different entities are taking care of it. If we look at Polish Waters or some other entities, the different companies will be responsible for it. Both the Water Framework Directive and NRR are in a dispute with agriculture. I'm going to talk about it in a moment. But I am serious. I don't want to speak for too long, but insofar as CAP, Common Agricultural Policy, no matter if we look at it from in Europe, from the right side or left side, we always have this problem. The greatest shared budget, 300 billion euro per year. I checked this. This is expenditure in France. 300 billions in France. In Poland, 200 billion euro yearly. So it's not a small budget, 300 billion. All those analysts, I'm not one of them because I'm a hydrologist, they stress that this number, which looks quite well, which means that direct subsidies are dominating, but we have this entire environmental component on 15%. So in majority of the countries, they simplify these schemes, those eco schemes, so there is direct payments, and they're quite simple. They don't generate disputes insofar as quality. In the majority of European countries, this part is very much simplified. Well, it doesn't develop in this direction of direct payments, which is the objective here. If we are talking about the big impact of Water Framework Directive, there is 0.3%, and ambitions are much greater. So obviously negotiation insofar as dividing the budget for common agriculture policy and its pro-environmental or eco schemes and strengthening agricultural production in Europe is its topic, and restoration potential, systemic, not only project restoration, it's its effect. And I told you that I'm going to show you recommendations. You read faster than I can speak as an element for discussion. How much we can find ourselves in what was said based on analysis, implemented projects in Europe. I'm just going to say one thing which was said here today, and I think that it was said also yesterday, the role of monitoring, and that we can learn from experience. I agree, but I've had Merlin experience. We had 18 projects, and it was between life and a scientific project. We had harmonized system of monitoring, of communicating data, storing data, collecting data, etc. And there were disaster or massacre, it was the lightest word describing the process of collecting data. It was really difficult within a project. So this is a challenge for our mentality. These are things that we give others, and there is a problem related to how to do it, and the rest you are able to read. Thank you very much.
Bardzo dziękuję.
Thank you very much, and I'll try to say a brief, to present a brief comment. We've had two professors who would like to say much more than they were allowed to, and later I was told to coordinate the discussion. It was a smart move, and something that I would like to recommend, and I would like it to become our leitmotiv, science versus reality. You can't separate the two, but let's make an artificial division for the sake of our discussion, or let's at least try, because you can't separate the two, and there is seldom an occasion to discuss activities, research and development activities, and implementation and project activity. It's very difficult to have the two aligned for different reasons. And first of all, and this is something I would like to stress to animate and trigger discussion. If you have a different opinion, please let me know, because the professor has mentioned a handful of passionate of people who are passionate about restoration. It's true, because restoration to date is presented and perceived as something done by activists, environmentalists, as a soft, not a fully fledged engineering task. So in social perception, it's not treated as seriously with the same gravitas as hard investment. In, for example, building flood prevention infrastructure, different engineering structures that help keep the flood at bay. And I have a sense that there is a very soft division between such perception, because this is should be perceived as a mitigation tool, and restoration requires social engagement. We've said it very clearly yesterday that without engagement of the right public, with a bottom-up approach, nothing would happen, and it's true. And I would like to thank and say I do respect everyone who's supporting restoration bottom-up. And there are many free initiatives or partisan activities, grassroots initiatives, and there is a very thin line between doing something what is robust and doing something what may prove to be dangerous. Not only because you can pose a threat to someone's security and safety, and because such measures, such activities may distort other projects implemented based on thorough analysis, which are more likely to achieve positive results. If we have 15 projects, 14 have been scheduled thoroughly, and one project is totally partisan and improvised, so negative outcomes of this one project may spoil the perception of all 15 projects, despite the fact that all of them are implemented by people who are passionate about restoration. So I think work of this academic forum is extremely important, because we need to send a very clear message to the wide public, not only to the world of academia. We need to get people to understand the dependencies in water management, in water engineering, and the conclusion must be very clear. We need to resort to very simple language, because we're still using jargon, we are using hard definitions. We prefer engineering definitions which do not fit the concept of restoration, and in regulations, in legal regulations, what is missing are definitions. We have fossilized regulations which are really ancient, and we are struggling to restore rivers because there are no applicable regulations in place. And by the way, this term is heavily abused. We are tempted to call everything restoration, and we do it, which is why we are creating a perception that restoration is a remedy to all evil of this world. And Professor Popek has mentioned it, sometimes restoration can be perceived as leaving the river on its own. It could be something else, but all those initiatives must fit the need, must be suitable to the issue we are addressing. So overusing the word restoration to solve the problem of drought or floods of anything else does more harm than good. Because without a robust plan, restoration will not work, and it creates a perception that anyone can take a shovel in their hand, that anyone can go and stop water flowing into the dikes. It's not so, and I'll be very happy to discuss it. I'm convinced you may think otherwise, and I'm open to discussions. And my project and engineering experience tells me that dependencies in hydraulics, in hydrology, the number of parameters and elements that have an impact on the outcome of activities undertaken by us, and spatial impact of our initiatives are so broad, are so unpredictable without a robust analysis that the likelihood that we'll be doing more harm than good is very high if we are doing things here and now. I understand the need, and I completely agree that perhaps very little is done systemically. But we can also take a course for worse, especially if we start acting with a limited picture in mind. We see, for example, a problem because there is a shortage of water and we want to do something to remedy it, and we are going to fill in a ditch. I'm sorry that I'm coming back to the ditch. I definitely assume that, this ditch we have discussed today, it's an informed decision. So what I have in mind are less project-based activities, but such interference in water flows in one site may have unpredictable effect if we don't have the right analysis in given time frames. Very often we are talking, why is a river drying if nothing has changed in the catchment area in the narrow sense, and in macro scale things look totally different. Because a kilometer, 5 kilometers away, a road is being built or remodeled, or a structured, a housing estate is built. Some alterations have been done to the landscape, plus additional activities that will have an impact on the river flowing several kilometers away. So without the right planning, without the sound assessment of risks to the entire catchment area, and we are focusing on the entire catchment area to reduce the likelihood of obtaining unexpected counterproductive results. And let me go back briefly to statements made by both professors. It's also food for thought. Perhaps I'm wrong, but I'm curious to find out what you think about it. We have mentioned engineering details and intricacies related to creation of the river channel. We were talking about refills and pools. Don't you have an impression that terms we are using as designers or as scholars and engineers, when we are trying to find solutions, that adapt the catchment area to flows. Perhaps those terms are too hard and too unified, and as a result, they don't open up. They don't allow us to translate those terms into deliverables we are looking forward to. And please note that during all presentations we were listening to while this conference lasts, we do not want to keep the river in check, but to adapt the catchment areas to water. We are trying to achieve resilience and not to design the river. This is not changing. Well, physics, computations remain unchanged. It's not that we were doing something wrong in the past, but we need changes in regulations, in handbooks, to better adapt to the new approach we are forced to take as a result of spatial planning, new spatial planning and climate change and the whole new situation. So I will ask Wojtek to share the position of Polish waters. Can you discuss administrative provisions and legal options you have in terms of water management? Because we are under a hard grip of regulations which force us to take a certain course. Okay, so I'm giving you the mic. If you could tell us more about financing and monitoring, which is super important and essential. So can we draw conclusions from mistakes we make? Because say for external financing, yesterday Professor Gregoruk stated there is no money left for monitoring. So please tell us if Polish waters have their own financial resources to do that, if they were deprived of external ones. Thank you very much.
Mogę krótko jak zawsze.
Oh, finally, it's my turn. I can't wait. So many important questions. I don't know how to start so our audiences are satisfied. Insofar as our administrative approach to the implementation of restoration tasks, I would say that at times it's more requiring and demanding for Wody Polskie, Polish waters, compared to other investors or participants of the project, because we have to work within the limits of the law. It doesn't change. It's about everyone. But the question remains if the binding vocabulary that Maciej mentioned, or understanding this vocabulary, does it fit to restoration measures? Because sometimes it turns out that restoration falls within the same legal paths or decisions, which may be too developed insofar as administrative permissions for implementation. There's the issue, the environmental issue, and also others. Our experience and also we have life projects and Phoenix projects. The administrative part is a big part of developing the entire project. Not the most important, but it's a part of the entire task. The question is, could we speed it up? It would require a certain change in approach. Maybe legislators, maybe the bodies responsible for passing decisions, but this is not a decision of one unit, of the management board of the catchment in Gryfice or some other. No, it would have to be holistic, which is more difficult to do. We talked earlier about broadening the catalog of maintenance measures or activities. Maybe it would be worth it to think about it differently, to create a catalog of restoration activities or measures, which would be under completely different legal conditions insofar as funding of tasks. Projects themselves, it's of course the external funding, national EU funding, funding of the monitoring and projects is absolutely possible. We are all aware of that. Is it possible after the project? Well, in my opinion, it is possible as the element of maintenance, especially if we have some installations, some pieces of equipment that serve the monitoring. Are these huge costs? I don't think these are big amounts. When I was analyzing what it looks like currently in a project, after the end of the project life and REGA, that ended in 2023, and we have made 23 migration devices, possible repairs and other costs, maintenance costs. It turns out that we are fulfilling the simple rule of 1-on-2. So 1% is maintenance cost every year, 1% for monitoring and 2% for repairs, which doesn't mean that 4% in total, this is something we may incur every year, but in a longer period of a few years, this is what it looks like, more or less. So it's simple to say, easy to say that in a period of 25 years, we'll have to, or we'll be obliged to spend practically yet another similar amount that was devoted to the implementation of the project in order to maintain its effect. I'm not even talking about heightening its effect, but maintaining it as it was at the day of the end of the project. Now, taking the opportunity of this short time that I was given before, the organizers are not looking at me with suspicion that I'm taking away so much time, I would like to relate to how I understand the implementation of tasks in general, restoration measures in a bigger kind of river like Rega. During these 2 days, it was already said that the implementation of one project is just the beginning, because we are unable to do it in such a way so project answers all the problems of a catchment. It's impossible. Such a big project couldn't be created or be actually implemented in a short time. So it would be good if these projects would follow one another in sequence, and together they would create a process of restorations, and the problems that they didn't know how to solve, or we learned about them later, and or maybe we found the knowledge later, these could be solved in subsequent years. I think it is related to progressing climate change, because if the climate will continue to change as we are forecasting it, then stopping restoration measures and just maintaining their effects results in the fact that we are going back, that we are not solving new problems that will accelerate. And this is related to what you asked about with the administrative approach, which should maybe in a way also answer these progressing and growing problems. So this is all insofar as my statement. I wanted to give you time for questions and for broader discussion. Thank you, Wojtek. So maybe we'll start the discussion. Questions to the professors, if they would like to somehow discuss it. If not, then maybe there are some voices in the audience. Please pass the microphone around. Tomasz Puczyński, Marine Institute. Mr. Wojtek, I have a question to you. Rega River Life project on Rega River, very big project. I was really cheering for it. But you are saying now that in order to maintain the effect, yes, there will be huge funds spent in a longer period. So what is the real effect of the LIFE project? Because I had the opportunity to do the monitoring of one of the species that was the objective of this project. And it's worse than earlier because this fish, lamprey, river lamprey or brook lamprey, the situation is worse. So the question is what to do with it. Well, the effect and the main objective of the project was to open the migration corridor of Rega and its tributaries. This is why there were these migration devices that were created, also spawning grounds, electrical barriers next to electric power plants. Within monitoring, we continue the visual monitoring. So this means that we are recording in 2 fish passes of the migration which is happening in there. On a current basis, the effects of the monitoring confirm that fish passes do work. So migration is taking place. And this is done by our contractor. He's preparing yearly reports about this, and the last one we will receive for this year. So I think that here this migration is happening insofar as fish. Insofar as specific data, I'm unable to give you this data right now. We would have to solve it after the meeting, because this is a big scope of data, of detailed data that I didn't prepare because we have a different topic of the presentation. But I can prepare it and share it. Just one comment. I think that the discussion will be followed because other people were tackling this topic also during the presentations by professors and during our walks in the riffles. This is a difficult topic, and the discussion is ongoing. The goals and effects, well, you cannot achieve them all, and the question is about priorities, about the approach to what we want to achieve at the expense of what, and are we able to put a price on it insofar as what is more important, what's less important, because unfortunately every time when we place several experts that assess a given activity, we will always find someone who will see the negative side. So the question is about how you can balance it out. Yes, exactly. I would like to talk about it. I would like to talk very generally with a proverb that you don't see the forest with all the trees. And very often what happens is that I have disputes with my colleagues hydromorphologists about what is the objective of all protection measures, restoration measures. Who is our audience? This is the question that we need to ask this. My clients are fish. They live there. They know what they need. So if I want to restore, rewild or anything, I need to ask the fish. This is the best that I can do. And we have to start with that. We published an article, Ask the Fish Restoration. That was the title. And it is about ourselves being aware of the fact that restoration should start with putting together the organisms that will benefit from the restoration. The next element is asking them, so testing their needs, and afterwards defining the measures, the activities that are leading to that. And unfortunately, because well, a long time ago in America there was a certain restoration industry where
Nie biorąc
So sometimes we can redevelop the channel, not taking into considerations that rivers are different and there are different species and living organisms living in them. And we need to keep in mind, and this is what's missing in such discussions, when we are getting to details, we tend to forget that this is the beginning of a plan. Later we create something and later comes verification. It's a matter of long-term monitoring to check what species are living in the river, because biodiversity is not a goal in itself. Okay, so I've said before that biodiversity and restoring cannot be treated as a remedy to all the evils of this world. So it doesn't matter whether it's a fish, a clam, or perhaps an insect. Without right conditions, it's not going to live in the water. But when we see that water conditions can be improved, it's just a matter of which methods could be harnessed to restore the river, and that's when we come to engineering, and later we can ask the lamprey or a mussel. Michał? I wanted to relate to what Professor Popek said, that restoration, it's an engineering venture. The river can restore itself, but it's a matter of time. How much this will take, it won't be a year or two. It will definitely take a lot of time. And when I watch restoration in Poland, what is missing are soft restoration activities. And I would like to make an appeal: in the future, we should address this topic. We should bring together a group of engineers to develop the right approach. Of course, I'm not talking about catalogs, I'm talking about the right project approach. Designers at project studios, when they are given a task of restoring a river, they should plan activities for a specific section of the river. Of course, we can choose initiatives from a restoration catalog, but we still need to take an engineering approach that fits a project. So it's a matter of changing definitions and terminology, which in handbooks, which in legislation are used today. And secondly, you've mentioned timeframes. This is an additional issue. We are impatient as people, as humans, and today we would like to do something and see results tomorrow. And a year or two, it's insufficient to evaluate results, and we have very little time to wait. So we are navigating those unstable waters, and sometimes time must pass because we have hydrological changes within a year. Sometimes we need to wait longer to see the actual results. Sure. And there are transformations and transitions that call for an intervention because the river would not cope by itself. For example, when you have lower current energy, you need to intervene. You need to restore the river, but it's not always the case that the river will restore itself. When you need to act fast, you need to have an administrative fast track, and that's an issue today. Regarding the issue you have tackled, because you've mentioned that there are no guidelines for designers. I would say that we can't have guidelines, because times of guidelines have produced engineered rivers. You know, they are technically engineered today. And I've been stressing time and time again that every river is different. We need to see what are the right morphological parameters of a given river, because it's very often the case that in the upper section of the river, in any section of the river, the entire course of the river has not been engineered. There are some natural sections, and a designer should test it together with scholars, with researchers, because like I've said, designing according to forex laws. And when we see what he did on the French rivers, he was researching those rivers extensively beforehand, and today designers are not going to pay to have, before the project is implemented, to conduct additional research for a year. And I believe that you can't apply guidelines. The guidance I've mentioned is presented in a catalogue of maintenance, of nature-friendly maintenance, which were put together as a result of the restoration program in Poland. So the catalogue features everything it should. And you can't create parameters for designers, parameters that are applicable to each and every river. I know what you mean, and you're right, but I just wonder if perhaps we don't know how to restore rivers, and we are afraid of failure so much that we are not going in the right direction, not every time. Well, usually you can't predict what's going to happen if we conduct robust research. We understand the physics of this phenomenon. It's not that the river is flowing because it wants to do so. I have no time today to discuss the hydrodynamic structure of the river and why is it that the rivers are meandering. But let me tell you one thing. Flight to the moon was possible back in the 1960s using a very simple computer. But a computer which is able to compute transition and alteration of the river with different sediments and a different course. Such computer was created only in the 21st century and not right in the beginning. So 40 or 50 years after the first flight to the moon, we only got a tool that enables us to compute how the river will be formed with a given current. And something that lasts seconds in nature, it takes hours to compute it. And we have mentioned it today, that application of models, of one-dimensional simple models which are applied by the Institute of Weather and Water Management to forecast floods and droughts. They're just computing water flow, and the debris sediments are not an element of this quotation. And if the bed load is missing in the river, or if its influx is limited, there will be no living forms. For example, that's the case in the river Vistula below Włocławek. The bed of the river is clear, and what effect does it have on the fish? My colleague professor can tell you. So it's not only water that is important in a river, but also the bed load. So the conclusion is simple: we need more knowledge, not another catalogue. Okay, Michał, sorry for chiming in, because I've been waiting in the background and I can't get hold of the microphone. There is a show of hand. I liked very much yesterday's presentation, which demonstrated that the river is more than a river, it's the entire catchment area, and we tend to forget that rivers are living organisms, and our specialties, we have hydrologists, we have hydrobiologists, we have hydrotechnicians. We should become more holistic, and I'm afraid that we won't be able to predict all changes, because rivers are dependent on hydrogenic habitats, and this is what determines life in the river. So it's extremely challenging. For example, lampreys. I don't know if lampreys have reduced influx of food. It might be the case. So we should see everything in a broader picture. Okay, so I've mentioned it, talking about a large number of dependencies. A river is by no means a simple organism. Okay, now Michał and Ania. Michał Miazga. We are implementing multiple restoration projects, and we are focusing on social issues as well, and this is something I'd like to discuss. Thank you, Maciek, for mentioning a very interesting social phenomenon which is now mushrooming, the restoration partisan activities. There are more and more people who want to get into action and do things themselves. I do encourage you to take a closer look at it, because it's a very exciting phenomenon growing in front of our very own eyes. These grassroots initiatives are mushrooming because we a community which is specializing in river restoration is not delivering. We were meant to restore rivers to prevent them from drying up, and they are drying up anyway. I'm not going to reinvent the wheel by saying we're not delivering. And if the state, if the system is not delivering, then you have grassroots initiatives, because people see a realistic need. If the system, if we are not delivering. And secondly, water grassroots initiatives in Poland have been with us forever. Ever since the time when the communism collapsed, we all know what owners of ponds are doing. They're stealing water. We all know that people release water into rivers and they don't give a hoot. So this is a grassroots initiative, very selfish. I would like you to take a look at those grassroots restoration activities. These people are our allies. Let's be clear, we are doing our best to deliver whatever we can in our line of work, but we are not delivering because procedures are too complex. The stream of money is not distributing money where it should be distributed. Perhaps money is not sufficient, perhaps we are struggling with ownership. But if we are not delivering, perhaps let's make the most of the social movement to have a bigger cloud. And let's play a good and bad policeman with decision makers. We can become the good policeman, but the power of the good policeman is effective when you have the worst alternative, the bad policeman, on the other side. And we've been testing it on several occasions. I'm not going to go back in history, but we are using this method very often in real life, in social life. So let's try to think we can do the same things we are doing now, but let's try to make the most of this power, of this potential, which is budding, to make the system more effective to deliver. Thank you very much. Okay. Anna Januchna-Szostak, Szczecin Institute of Technology. Tomorrow I will tell you more about it, but today I would like to comment on the catalogue of activities. It's more about structuring. I think we should be able to interpret a river as a catchment area, a channel, and to solve all issues with the water level, because sometimes there is a shortage of water, sometimes there is excessive water, and we need to factor in the catchment area as well. We used to discuss that urban planners do not have the catchment area inside. They have no information because there is no such legal provision which commits us and enables us to balance water levels in spatial plans. Because we are modeling the channel, we are modeling flow, floodplain, but the information is not carried upstream to do restoration, impacting small tributaries. We are not communicating information about potential effects of urban planning. Okay, again, it's a question of knowledge, understanding, and legal regulations, and there is a gap. There is water in the river, but the tributary of the river is no man's land. So it's a planning problem that has vast impact on what happens later to the catchment area in the city adjoining to it. Weronika Sęczek, I'm a designer. And when we talk about guidance, I have to say that I agree with the professor, because we can't propose a specific catalogue of activities that we can later choose freely from. We should suggest guidance for the project process, guidance for designers, since there are so many variables which have an impact on the catchment areas, on habitats. So when you have a tender for restoration of a river, we have a number of requirements regarding the analytical system of the designer. The designer has to plan contribution of certain experts. He or she has to conduct certain analysis relying on his or her engineering competencies, and finally offer tailor-made solutions for a given river, for a given section, on a given scale.
In such guidelines, I think that this is something which is reasonable and would be very much needed, especially for designers. I'm a hydrotechnician, I'm a landscape architect, but there are not many hydrotechnicians, because besides me there was only one more designer graduating when I was graduating. So there are not many of us. So we have knowledge from old drainage handbooks. We have a lot of information from conservationists or environmentalists and various specialists. And what we need is that well, we need to take that all into consideration. And to be honest, I still feel that these people who are dealing with drainage are those bad people who destroyed nature. But drainage specialists had knowledge which we need now in order to reverse the effects of these works. So I would like to recommend us to go hand in hand and not say, no, engineers, no, because they did only wrong things. I think we have some expertise that could be useful. Well, it's the same knowledge in general, just the views change, yeah. The problem is different to solve. So there is the idea of the green drainage engineer, or there are many ways of describing such a person, but this is just a side comment. Ilona, ladies and gentlemen, but that's going to be in a moment. I believe
Coś, co sądzę, że
I'll propose something that Madam Professor will like very much, Professor Wagner, because, ladies and gentlemen, what we are talking about here, these voices that you're hearing here, it's really resonating with me, especially what Professor Okruszko said. The first slide, we are talking about the voice of the rivers, but Magda says organisms are also people at the river. We're talking about guidelines, about designing. Our colleagues who have been operating for decades, after 30 years, have the effect of their activities come through, and we keep turning in the same bubble. So I don't want to say that we have foreseen it in this conference, but the tool that we've proposed to work, the roadmap, restoration roadmap, is something that actually comes from your doubts and questions. So I have a proposal. Let's move over there. Let's go there. Let's stand in front of river restoration roadmap and let's start to discuss this tool. Magda, can we count on your moderation? Because let's leave this room. Because I think it's 6:35. No, it's almost 7. And let's leave the standard. Let's go up to the map and the interpreters. Well, I think we'll thank you for your work, because we need some creative work, right, director? No, I saw that Professor had her hand up for such a long time that we cannot leave her. Okay, the voice of Madam Professor, because she was co-creating this roadmap. Okay, so thank you very much. It's true, I have also the feeling that what you're talking about should be placed on the map. 100%, but yes, I was having my hand up for a long time, so at least 3 voices, 3 opinions. No, I'm sorry, I forgot. No, 3 opinions that I completely agree with were before me. First was Piotr, who said there are many aspects. There are things that Professor Popek mentioned, water, matter, or sediment. There is the issue of organism, of feeding the river, but also the limestone that will change the equilibrium for various trophic levels. And there is a need of so many specialists, of very narrow domains. So we need to collect it all together. What Veronika said, it also resonates with me. Veronika said that we don't need a guideline within going right or going left, but we need specific steps to do. What we need to do? Start with the catchment analysis. This has to be there. Look at the valley, look at the river. Look at biotic structure. You have to think towards this direction. And the project of restoration, yes, look at the people. But this process, it's not work for designer. This is for a collection of specialists. And it would be great to have guidelines within what we have to do in order to restore the river. I don't think we have time to worry about how long we will have to wait for the effects, 1 year or 3 years. It's not like the concrete slab that when you put it down, it looks good. This is the nature of a living thing, and a river is a living thing. Mr. Piotr, I'm sorry, I don't remember the name, or maybe I don't know. He mentioned about Michał, how angry the society is, the public is, and this is why there is this partisan work. And I agree, people simply want change, specific change, concrete change. We can't deliver, we don't know how to do it, and once we see how mad they are, how angry they are, we need to use this anger to engage them in social consultations. They do exist, but it's almost like they didn't exist. They are unique. And it seems to me that this is the moment to really tap into the potential which is in people, because the experts process has to be broadened with the society. Another thing that I wanted to mention is the law. Construction law is something that we clashed with when we were developing our project, like Radom Klima, because first Mleczna River, there was the issue of competences of the staff and the perspective and the huge social and institutional process standing behind it. We had designers who wanted to put some concrete. There was WWF that wanted to just start doing it. There was the city that said, yeah, but the water will come in through the drainage system. And there were so many competitive needs, contradictory needs, that we ended up with a river which is restored, which is doing very well, because we are working on the results after 6 years, and we see what is changing. It's a beautiful river, but it started with concrete meanders, and I know it's not a perfect situation, but it was the only way for us to develop any compromise. It was a very difficult, very emotional process. I could talk about the details later. And the last thing about construction law, because all investments in this project was done by Radom Waterworks, and the coordinator was clashing with the construction law every day. How many times you have green and blue infrastructure or restoration or any plant in the construction law? Zero, exactly. You cannot describe a construction project, so it serves restoration, and it's necessary. And I have many other examples. I was able to buy out some lands. The people who were proposed these mechanisms, they were very happy because these were wetlands. You couldn't build a house there. We were able to buy it, but it was based on anti-flood special law. So we had to have some additional solutions.
Który trzeba zmienić, trzeba.
Iwona, tu zwróć uwagę.
So there are many things that we need to change. Pay attention to one thing. There was one more topic which is maybe not really presented here. It was not really developed. Mleczna went to the right direction, among other things, thanks to the fact that there was openness to critique and discussion, because it was bad at the beginning and it turned out to be good. And today we talked about it, that there is a problem in this industry, broadly understood hydromorpho environmental sector, to face the mistakes and to discuss them openly with everyone. We have a problem with that. All of us have a problem with that, and it's a problem. It's a problem because we don't have anything to draw conclusions with, because we are hiding our mistakes. Like our colleagues said, we are afraid to act because we're afraid of mistakes, errors, and we're afraid to be criticized. And we should be discussing these things. This is yet another theme. Yeah, let's end this part here. Those who are interested to come up to the roadmap, we will start this discussion with the roadmap creation. Thank you very much. It turned out really well. Thank you so much for all these questions and comments. This shows how much we still need to summarize.